Hi, I'm Joseph, and I'm going to describe a recursive function that takes a valid binary tree and determines whether it is a binary search tree or BST. A binary search tree follows a strict rule. Every value in the left subtree must be less than the current node, and every value in the right subtree must be greater than the current node. What's important is that this rule applies to entire subtrees, not just a node's immediate children. To check this correctly with recursion, the best approach is to carry a valid range down the tree. So start at the root with an allowed range of negative infinity to positive infinity. For each node, verify its value is inside that range. Then recursively check its children with updated ranges. The left child must be within range, the minimum to the current value, and the right child must be in range, the current value to the max. So the recursive function looks like a tree, conceptually. The base case, if the node is null, return true, an empty subtree is valid. If the node's values is less than or equal to the minimum bound or greater than or equal to the maximum bound, return false. For recursive steps, we return the result of checking the left subtree with the updated max bound and checking the right subtree with the updated minimum bound. In pseudocode, that sounds like is BST, open parentheses, node, comma, min, comma, max, close parentheses. If node is null, then return true. If node dot value is less than or equal to the minimum, or node dot value is greater than or equal to the maximum, return false. This works because each node is compared not only to its parent but also to the constraints passed down from all ancestors. That prevents the common mistake where a tree looks correct locally but violates the BST rule deeper in a subtree. Finally, the performance is efficient. We visit each node once, so the time complexity is big O of n, where n is the number of nodes. And that's the recursive range-based method to determine if a binary tree is a binary search tree.